Alright, good day and welcome to learning exercise 8.5. In this exercise we will learn how to sketch a cubic function when an equation is given. Transitional work. So generally we give you an equation, they have x cubed minus 4x squared minus 3x plus 18. Number 1, can you determine the y-intercept? So y-intercept, x equal to 0, so instead of having f of x, now I have f of 0. If I put in 0, I'm left with 18. So my y-intercept is x is 0, y is 18. Determine the x-intercept. First we have to find the linear factors of 18. So those are all the values we will test. Plus minus 1, plus minus 2, minus 6, etc. So when we test, the first one that I tested, when I put in minus 2, it gives me 0. So I should know then x plus 2 is a factor. Now I'm required to factorize it to find my x-intercept. So if I'm given f of x equal x cubed minus 4x squared minus 3x plus 18, then f of x equal x plus 2. X times x squared gives me x cubed. 2 times positive 9 gives me 18. They have 2x squared minus 6x squared. So minus 6x squared plus 2x squared gives me minus 4x. So for that there you can refer to learning exercise 7.2. Factorize further, that becomes x minus 3, x minus 3. So here I only have two x-intercepts, x equal minus 2 or x equal to 3. Alright? So number 3, calculate the coordinates of the stationary points. So get the stationary points, I take my equation and I find the first derivative. So 3 times 1 stays 3, 3 minus 1 becomes 2, 2 times negative 4 becomes negative 8, 2 minus 1 becomes 1, 1 times negative 3 becomes negative 3. Remember, first derivative of a constant, always 0. Then we make the first derivative equal to 0. For my stationary points, first derivative is 0. So there's 0 equal to, if I factorize, 3x times x gives me 3x squared, minus 3 times 1 gives me negative 3, negative 3 times 3x, negative 9, plus 1x gives me negative 8x. So I have x equal minus 1 over 3 or x equal to 3. These points that I get must be substituted back into the original value or equation to get the y values of my turning point. So I substitute into original equation first, minus 1 over 3 wherever x appears. See, minus 1 over 3 cubed, minus 1 over 3 squared, 3 times minus 1 over 3. If I simplify, that gives me 500 over 27 or 18,52. So coordinates, minus 1 over 3 and 500 over 27. Go to the second one. If I substitute in, remember x equal to 3. Substitute in 3 wherever x appears. So there I would have 3 cubed minus 4 times 3 squared minus 3 times 3 plus 18. That then becomes 0. So there my other coordinate is 3 and 0, meaning it turns on the axis. Right? Further, find the coordinates of my point of inflection. So my first derivative I found previously were 3x squared minus 8x minus 3. So second derivative, 2 times 3, 6. 2 minus 1, 1. 1 times negative 8 gives me negative 8. 1 minus 1 is 0. Anything to the power 0 is 1. Again, point of inflection must then equal 0, or my second derivative. So 0 equal to 6x minus 8. Now we solve for x. Take 8 across, positive 8. 6x equal 8. Divide 8 by 6. That simplifies to 4 over 3. Right, so my stationary point, I have that as my x coordinate. And then I have to always substitute back into the original equation given. So there I go back in this equation given, x cubed minus 4x squared minus 3x plus 18. So if I substitute back in, I get 250 over 27. So there's my coordinates. Now I'm required to plot them. So I plot. Remember I have x-intercepts minus 2 and 0 and 3 and 0. So there were my two x-intercepts I calculated, minus 2 and 3. right? Then I have my stationary point, minus 1 over 3 and 18,52. So there were my stationary points, minus 1 over 3, 527, and 3 and 0. So you see my secondary stationary point is on that same point. Right, I can plot in the point of inflection, which is effectively 4 over 3 and 250 over 27, which would be somewhere roughly about there. And then I have a y-intercept at 0 and 18. Right, so that goes through 0 and 18, and then I join them up, and there's the graph. Right, so take note, as you can see here, x cubed equals positive. So if x cubed, or the a value of x cubed, is positive, basically what transpires, my graph goes concave down to concave up. If a was negative, my graph would be concave down, going to, or not concave up, to concave down. So they have concave down, concave up, and that can also change. Right? All the best. Hope you understand. God bless. Bye.